Okay, so this is our trig review again for the final, and we're looking at the definitions of the three trig functions, the cosine and the sine and the tangent of various angles. We've covered right angles, so now we're looking at the unit circle approach, unit circle. This has a huge advantage over triangles simply because unit circles are applicable for all angles, not only acute angles. So all angles, both positive and negative. So we can have theta can actually be any real number from negative infinity all the way to positive infinity. Okay, so any real number angle, we usually measure theta in radians, but we can also do this in degrees if we want, radians. Okay, so here's the idea. First of all, we define in algebra class the circle centered at the origin with radius 1. So this is the ordered pair 1, 0. This is the ordered pair 0, 1, and the ordered pair negative 1, 0, and the ordered pair 0, negative 1. The radius of this circle from here to here is exactly 1 square unit. Okay, and then the next thing we do is we define angles in standard position. So start with the positive x-axis as one side of the angle, and then if you rotate counterclockwise, these will be positive angles. So this angle theta has a positive measure, and the default unit of measure is going to be in radians. We will convert radians to degrees occasionally, but here we have a positive angle. And if we go in the clockwise direction, say here, again, starting from the positive x-axis, but now rotating, let me take away my radius here. If we rotate in a clockwise direction, we'll end up with negative angle measures. So again, you can rotate, and you can rotate as far as you want, even past 180 degrees. So here's an angle rotating this way that would have a, let's call it something besides theta. We'll call that one, how about phi? So use another Greek letter. And so phi has negative angle measure. Okay, so that's the first thing we have to deal is positive and negative angles. Now, how do we define the trig functions in terms of this? It has to do with the terminal point, or the point on the terminal side of each angle. So for this angle theta, this blue in here, we're looking at this point. We need to know the coordinates of that point, coordinates of this point. And likewise for the negative angle, again, where the initial side is along the positive x-axis, but where the terminal side of the angle is, we have a point, so I need to know the coordinates. Now, our definitions go this way. If we're on a unit circle, let me minimize this a little bit. There we go. The cosine of the angle will always be the x-coordinate. The sine of the angle will always be the y-coordinate. And the tangent of the angle will always be the y divided by the x-coordinate. And that doesn't matter whether the angle is positive or negative. So it all boils down to what is the ordered pair that goes with these terminal points. Okay, so there's a couple of ways you can do that. Let's do the generic way where I simply just give you a number. Let me get a new circle going here a little bit larger. Okay, so this is our unit circle. And let's go in the first quadrant. And let's say the ordered pair here has an x-coordinate of, that seems to be about 3/5. Okay, so from here to here is 1. So there's 1/5, 2/5, 3/5, 4/5, 5/5. So let's say this is 3/5. And our task is to find all three trig functions, the cosine, the sine, and the tangent of this angle theta, where theta is measured from here to there. There's theta. Now, if I told you the point had an x-coordinate of 3/5, this answer's done. because we know the cosine of the angle is always the x-coordinates, and I gave it to you. It happened to be 3/5. Great. Unfortunately, I don't have the y-coordinate, and I would need that for both the sine and the tangent. So we're going to have to do a little bit of algebra. We know the equation of this circle, the equation of the circle centered at the origin with radius 1 is x squared plus y squared is 1. And we know x squared is 3/5, so we can put that in. 3/5 squared plus y squared is 1. And we can solve for y. Y squared is 1 minus 9/25. I squared the 3/5 there. So y squared is 25/25, take away 9/25. Y squared is 16/25. So y would be, now typically plus or minus 4/5. We do note that y in this case is up in this quadrant 1. So y has got to be positive 4/5. Now that took a little bit of work, but it does allow us to easily get the sine is 4/5. Remember, the sine is the y-coordinate. And the tangent, we would have 4/5 divided by 3/5. And hopefully you can simplify that. 4/5 times 5/4, or simply, 4/5 times 5/3, Joe. And the 5's cancel. So we get 4/3. Okay, again, using the ratio y over x. Okay, so that wasn't too terribly bad. I can give you any point, obviously, where x could be any number between -1 or +1, and you could calculate the corresponding y if you knew which quadrant we were in. Okay, now let's try one more like that just so that you could sort of get a feel for that. I'm going to take my unit circle. This is the unit circle. And this time we'll pick a point down here in quadrant 3. Remember, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, always using Roman numerals. And I need an ordered pair for that. Well, let's see. This is -1 way over here. And this almost looks like -1. Let's say we're all the way over here, and we'll pick -9/10. Okay, so the ordered pair here is -9/10, but I don't have the y-coordinate. And the task is to find all the trig functions, cosine, sine, and tangent for this angle. And let's make this one negative. It doesn't much matter whether we go negative or positive. The terminal point is what we're concerned with. So we'll call this angle theta. And once again, I need the cosine of theta, the sine of theta, and the tangent of theta. In this case, I gave, again, the x-coordinate. So the cosine is given. It's -9/10. And the task is to find the sine and the tangent. Once again, we'll jump to the equation of the unit circle. X squared plus y squared is 1. So -9/10 squared plus y squared is 1. 81 over 100 plus y squared is 1. Y squared, if we subtract off, we should get 19 over 100, right? Because 1 is the same as 100 over 100. Take away 81 over 100, and we get 19 over 100. So y is going to be plus or minus the square root of 19 over 100, or if you want, plus or minus the square root of 19 over 10. And again, looking at quadrant 2 this time, we know that we're going to have to, for the plus minus, we need the negative root, not the positive root. So we'll take the plus minus away, and we say, since we're in quadrant 3, the y is negative square root of 19 over 10. Okay, so and I'll go ahead and put that right there. Negative square root of 19 over 10. Okay, once we've done that work, then we can go back and fill in these slots. The sine is negative the square root of 19 over 10, and the tangent is the y-coordinate, negative square root of 19 over 10, divided by -9 over 10, which works out to be the square root of 19 over 9. The 10's cancel, the negatives cancel, and we have the square root of 19 over 9. Okay, so that's a nice couple of examples. We have the definition on the unit circle. We have an example where x-coordinate was given. We had to find the y-coordinate. And we have the example where, again, the x-coordinate was given. We had to calculate the y-coordinate. Now, the most frequent use of the unit circle is not for those arbitrary angles, but rather for standard angles that we'll see again and again and again. So let's see, let me pull up a blank spot on my page here, and I'll go ahead and draw a slightly larger unit circle, and I'm going to put in an angle of 45 degrees going that way, and negative 45 degrees going that way. We'll also put in the 30 degree and the 60 degree angles. And these are our standard angles that you should know for your unit circle. These points you don't have to calculate. These points you're going to be memorizing. So let's just go ahead and label this point 1, 0. This point is going to be the square root of 3 over 2, comma 1/2. This point is going to be the square root of 2 over 2, comma the square root of 2 over 2. This point is going to be 1/2 the square root of 3 over 2, and the top of the circle is the ordered pair 0, comma 1. Okay. These ordered pairs for the first quadrant are all duplicated in the various quadrants just by using symmetry. This point, for example, would still have the square root of 3 over 2, but now the y-coordinate would be negative. This point way over here would have a negative square root of 3 over 2 for the x, and the y-coordinate would still be 1/2. It's still 1/2 of the way up. And I think for learning purposes, it's really useful to look at the halfway marks. So these green lines going this way are halfway up the y-axis. Let's do red ones for halfway on the x-axis. This red is halfway on the x, and so is this one. So if you look at those points as halfway points, it makes sense that this is halfway on the x. And likewise, down here, this is going to be halfway on the x. This one, we have a negative 1/2 on the x, negative 1/2 on the x, square root of 3 over 2. And down here, you would have negative 1/2 on the x and negative square root of 3 over 2. Let's go ahead and throw these guys in. This is going to be negative square root of 3 over 2, 2, and negative 1/2. And then the only ones we're missing are the 45 degree lines. So this one, again, just the same root 2, this time negative, and then positive. Down here, this one, both x and y would be negative. And over here, just the y is negative. Okay, so you should certainly have these points memorized, and obviously the ones on the axis are critical as well. So 0, -1, and over here we're at -1, 0. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 ordered pairs must be memorized. Ordered pairs must be memorized. Use the halfway points again to help you figure out which ones are halfway across and halfway down. So the green ones here are halfway up as you go from the origin up to the top of the circle. This distance, this green one is halfway. And as you go down to the bottom of the circle, the green one's halfway. And the same thing with the reds. Now, as you go to the right, the red one is halfway across, and going this way, the red one is halfway across. And that will help to get you these x and x. We'll throw negative square root of 3 over 2 here. X and y numbers. Okay? Now, very closely related to this picture are the angles that go with it. So yeah, you need to know the angles that are associated here. This is pi over 6. The next one going up would be pi over 4. The next one is pi over 3 going all the way to there. And at the top you have pi over 2. So let me go ahead and stop this video here. We'll pick it up again looking at the standard angles, pi over 6, pi over 4, pi over 3, pi over 2, going all the way around, positive and negative, so you can get those with this picture.